that we know how to graph stuff with systems of equations and find solutions, we need to talk about the different types of systems of equations. There's two types, consistent and inconsistent. These are basically just vocab words that you need to know. If a system of equations is consistent, then there is a solution. If there's a solution, if I'm graphing these, then that means that the two lines cross. If it's inconsistent, then there is no solution. How could that be? The lines don't cross. What kind of lines do we know of that don't cross? Yeah, they're parallel lines. So the two lines don't cross. And in parentheses, I'm going to say because they're parallel. Consistent, inconsistent. Which one sounds better, consistent or inconsistent? Consistent. So if we're trying to find a solution, the one that sounds better, consistent, is the one that has a solution. The inconsistent one doesn't. Okay, now if a system is consistent, then there's two ways that we can have a consistent situation where we have solutions. So because it's consistent, there's solutions. If it's independent, the lines cross, meaning one solution. If it's dependent, then the two lines are exactly the same. Which means the two equations are also exactly the same. And in this case, that means that the ordered pairs for one line work for the ordered pairs for the other line as well. How many ordered pairs are there on a line? So many? Do we have a word that means that many? Infinitely many. Infinitely many solutions. So, all systems of equations are either consistent or inconsistent. Either they have solutions or they don't. If the two lines are parallel, then the system is inconsistent. If the two lines are not parallel, then the system is consistent. You have a solution, at least one solution. Now, if it's consistent, then it's either independent or dependent. You either have lines that cross, maybe they look like that, or you have two lines that are exactly the same, and maybe I have a line that does that, and then my second line goes right along with it. It's exactly the same line. If that's the case, then you have infinitely many solutions. So you're going to look at the equations. If the equations are exactly the same, then it's a dependent system. If they're not exactly the same, then take a look at the slopes of the two lines. For parallel lines, the slopes are going to be what? The same. Will the y-intercepts be the same as well? No, they won't. If the y-intercepts are the same and the slopes are the same, then what do we have? This case right here, the exact same equation. But if the slopes are the same and the y-intercepts are different, then you have inconsistent. Because they're parallel lines, they won't cross. Any other case, if the lines aren't parallel, if they don't have the same slope, then you have independent. The lines will cross. So all we're going to do in these problems is basically look at the slope. If the slopes are the same, then look at the y-intercepts. All right. Graph each system and determine if the system has one solution, infinitely many solutions, or no solutions. What this is doing is it's asking you to say, really, is this system consistent, or inconsistent? Is it independent or dependent? Using those vocab words. So, it says graph them, so what do I have to do for that first one? Yeah, it needs to be in slope-intercept form. So this one on the bottom already is, but this one isn't. So what do I need to do? Add x to both sides. When I do, I get 2y equals what? I added x to both sides. X plus 2. Now what? Alright, we divide both sides by 2. Every little part, and we get y equals 1/2 x plus 1. So we can graph that. 1/2 x plus 1. The plus 1 is there, then the 1/2 says up 1, right 2, over and over again. Reverse it, down 1, left 2, over and over again. Okay, so there's my line for this equation right here. So now I'm going to change colors and graph this equation right here. How do I graph that one? Yeah, we have a y-intercept of 1, and we have a slope of 1/2. It's exactly the same equation. I actually didn't even need to graph this one before I knew the answer, but it asked us to, so we'll go ahead and graph it. But it is exactly the same graph, even though my ruler was slightly tipped. So, does this have one solution, infinitely many solutions, or no solution? Infinitely many solutions here. Let's use the vocab word too. If it has infinitely many solutions, then what kind of system do we have? Inconsistent is when you don't have any solutions at all. This one is dependent because they are exactly the same equation, exactly the same line. You have infinitely many solutions. So I'm also going to write dependent here. It's an important vocab word. Okay, let's graph the other two now. They're both in slope-intercept form, which is nice. So for the top one, how am I going to graph it? Start at 2. Up 2, right 1 each time. Good. And then reverse it. And draw on the line. Hopefully you're getting faster at drawing lines in slope-intercept form. Okay, there's my blue line. And how do I graph my red line? Starting at -1 this time. Good. Now what? Up 2, right 1 each time. What do you notice about these two lines? They're parallel. Did I need to draw the graph to say that they're parallel? No, not really, because all I had to do was look at what? The slope. Because the slopes here were the same, I know that the two equations are parallel. So there and there. That's awesome. Thank you. I have no idea. Yes. So that was kind of what I was asking earlier. Notice that these are parallel lines because they have the same slope but different y-intercepts. If I had a -1 here and a -1 here like I do now, then would these two lines be parallel? No, what would they be? They'd be the same exact lines. So in that case it would be a dependent system. But now these are parallel, so the vocab word I want to use is what? Inconsistent. Good. And inconsistent means how many solutions do I have? No solution. These lines will not cross. So technically, you don't have to graph these problems to figure out what the answer is going to be. One solution, infinitely many solutions, or no solution. What would no solution? Well, sorry, what would one solution look like? Yeah, it's just two lines that cross. Maybe one line does this and the other one does that. That is one solution. They cross once. There's only 3 ways that lines can appear together. Either they cross, or they're parallel, or they're exactly the same. Okay? So that's why there's only 3 possible answers on these problems.